I'm Sung, and I'm the Principal and Director of Sky Academy, and we've been looking at linear functions, and in this episode we're going to be looking at different forms or different ways that you can express linear functions and work them out. And we are going to be looking at a particular form, this form here, where it looks like this: y equals to 2x minus 3. Y is equal to mx plus b is the general way that we express it, where m is one number and b is another number. And we are going to look at what m stands for and what b stands for, because that's particularly interesting. Now, as a hint, the form of this function, or this linear function, is called the gradient intercept form. Okay, it's called the gradient intercept form. So that's going to be a hint as to what m and b stands for. In this particular case, m is replaced with the number 2, and b is replaced with the number minus 3. Okay, x and y are your two variables. You need x and y to remain x and y. They won't be numbers. They actually are the governing variables of this function. So in other words, x is called your input, right? The numbers that we put in, and here are the numbers that we're going to put in, and y is your output. It's the numbers that you get out. Okay, so let's say we put minus 2 in. Minus 2 times 2 is minus 4, or negative 4. Minus another 3 is minus 7. Minus 1 we put in, ends up being minus 2 minus 3, it's minus 5. 0 we put in, and it's minus 3. And see how we're going up by 2 each time? So 1 we put in, and 2 minus 3 is minus 1. 2 times 2 is 4, minus 3 is positive 1. 3, put 3 in, 3 times 2 is 6, minus 3 is 3. 4 we put in, 4 times 2 is 8, minus 3 is 5. And here we have a classic number line for this particular form of a straight line. When it comes to plotting the points, this is what it looks like. We'll start at 0, which is 0 minus 3. So that's that point there. Let's say minus 3 there. And then it also passes through 1 minus 1. So let's say 1 is there and minus 1's there. Alright, also passes through 1, 2. So 1's there and 2's there. 3, 3. So 3, 3 there. And then it'll just keep plotting along, and it'll be a straight line. What you'll notice is that it's a straight line that takes on this form. Y equals to 2x minus 3. Right? What I want you to notice, right? Well, what point would that be there? It would be, say, for example, it's the point that makes y equals 0, and it would have to be 3 on 2. So this point here would be 3 on 2. This point here would be minus 3. But what I want you to notice is that the point where it crosses, and this is called the y-axis, where it crosses the y-axis, right, is at minus 3. The back end of the function, this minus 3, corresponds to where it crosses the y-axis, right? That 3 is called your y-intercept. And it's when x equals 0, right? Happens when x equals 0. When x equals 0, that will disappear, and so that number there is your y-intercept. So in your gradient intercept form, y equals mx plus b, your b represents your y-intercept. Does that make sense? Your m, therefore, given that it's called the gradient intercept form, m would represent your gradient. And let's see if that's true, right? Let's see if the gradient really is, in this case it'll be 2, right? Let's see if that's true. So let's choose any 2 points. Let's choose these 2 points and these 2 points, right? That will be x1. This will be y1. That'll be x2. This will be y2. So let's check that out, okay? That probably didn't come out properly with the pen. So I'll do that like that again. So let's work out the gradient. So m equals to y2 minus y1 over x2 minus x1. Well, we don't know it's the m just yet, so let's call it the gradient. y2 is 5 minus negative 3 all over, and in this case it's 4 minus 0, right? 4 minus 0, and you get 5 minus negative 3 is 8 on 4 minus 0 is 4, which is 2. And 2 is equal to m, because m is this point here. Do you see that? So in other words, m will be our gradient. And we notice that to be the case. As we're running across 1, see the gap between here and here is 1, and the gap between there and there is 1. The gap between there and there is 2. And all the way across, the gap between each of these points is 2, and the gap between each of these points is 1. And so our rise over run will be 2. 2, you're rising 2 for every one that you're running, so your gradient's going to be 2. So your gradient intercept form, m stands for your gradient, y stands for your y-intercept. What does that mean? And will that work in every case? And the answer is yes, it will work in every case. So what does that mean? It means that if you have any linear function whatsoever, let's say y is equal to negative 3x plus 4, then minus 3 would be your gradient, 4 would be your y-intercept. And that means we can draw any function, right? It also means that any function that is linear but is not in gradient intercept form, we can work out the gradient and intercept by putting it in gradient intercept form. So for example, if you had 4x plus 2y minus 6 equals to 0, you could easily put that in gradient intercept form. The way you do that is you make y the subject of the formula. So let's do that. 2y is equal to minus 4x plus 6, and we did that by bringing the 4 over to the other side and the minus 6 over to the other side. Divide both sides by 2. Y is equal to minus 2x plus 3, and this has a gradient of minus 2 and a y-intercept of 3. We can now graph this linear function. Okay, so it will just simply be a graph with the y-intercept 3 and the gradient being minus 2. Instead of being that way, it'll be this way now. So that's what it'll look like. Okay, y is equal to minus 2x plus 3. Okay, so it'll take you some time to do some practice with this stuff, but that will significantly come easier with a little bit more practice. Alright, thank you very much for watching.